Representing inequalities. In this video, you'll learn how to write inequalities that represent the constraints in a situation. So let's look at these linear inequalities. An inequality is a mathematical statement that compares two values or expressions using symbols. The symbols that we use are greater than, less than, greater than or equal to, and less than or equal to. We can determine which symbol to use by looking at the relationship in the key words. So let's look at each inequality a little deeper. We'll start with greater than. Some keywords we might see for this is more than, larger than, exceeds, or above. For example, if we have a situation where you'll get a ticket for speeds exceeding 60 miles per hour, then we can write this as x is greater than 60, since any value greater than 60 results in a ticket. Now let's look at less than. These keywords might include fewer than, smaller than, under, or below. So if we have a situation where you must be under 12 years old to order from the kids menu, we can write this as x is less than 12, since any values less than 12 can order from the kids menu. Now let's look at greater than or equal to. These keywords are at least, minimum, or no less than. So if you need at least 18 credits to graduate, we can represent this as x is greater than or equal to 18, since you can have 18 credits or anything more than 18 to graduate. Finally, we have less than or equal to. Their keywords are at most, does not exceed, and maximum. So if we have the maximum value of a gift card is $20, then we can represent this as x is less than or equal to 20, since the gift card value will be $20 or lower than that. Let's practice by writing a linear inequality for each situation. A rectangle has a length of 4 meters and a width of w. The area cannot exceed 100 meters squared. So we know that the area cannot exceed. So that says that we'll use the symbol less than or equal to. So we can write this as the area must be less than or equal to 100 meters squared. And we know that the area is found by taking the length times the width. We know that the length is 4 meters and the width is just w. So we'll replace L with 4 and w will remain the variable. Here's another situation. Weekday tickets, which we'll call W, and weekend tickets, which we'll call D, must exceed $4,000 total. Since we see that it must exceed 4,000, we can write this as tickets must be greater than 4,000. And since we know the tickets come from weekday and weekend tickets, we'll add both of those together. And together they must be greater than 4,000. Here's one more. Elena wants to work more than 5 hours, but no more than 20 hours per week. Since we see that she wants to work more than 5, we can represent this as x is greater than 5. And since she wants to work no more than 20, we'll write this as x is less than or equal to 20. Since she can still work 20 hours, she just doesn't want to go over that. And since we have two inequalities, we can put them together by putting x in between our boundaries of 5 and 20. Now let's look at this example and try to analyze different inequalities that we see. Jada is making lemonade for a party with her friends. She expects a total of 5 to 8 people to be there. She plans to prepare 2 cups of lemonade for each person. The lemonade calls for 4 scoops of lemonade powder for each quart of water, and each quart is equivalent to 4 cups. Let's start by labeling any variables and unknowns that we have. We'll call C the cups of lemonade, and N the number of friends, and S will be the scoops of powder. So let's look in our problem and see what we can pick out. We see that she expects a total of 5 to 8 people to be there. So we can write this as N is greater than or equal to 5 or less than or equal to 8, since the number of friends will be between those two numbers. We also see that she plans to prepare 2 cups of lemonade for each person. So we can write this as C equals 2N, since the number of cups she needs will be 2 times the number of friends that are there. And then we see that the lemonade recipe calls for 4 scoops of lemonade powder for each quart of water, and each quart is equivalent to 4 cups. We can write this as S is equal to C, since there are 4 scoops of lemonade powder and there are 4 cups at each quart. Here's one more example. Jane wants to build a doghouse and she makes a list of the materials that she needs. So she needs at least 60 feet squared of plywood for the surfaces. She needs at least 36 feet of wood planks for the frame of the doghouse, and she'll use between 1 and 2 quarts of paint. So let's represent these by using inequalities. Since we know that she needs at least 60 foot squared of plywood, we can write this as P is greater than or equal to 60. And then we know that she needs at least 36 feet of wood planks. So we can represent this as W is greater than or equal to 36. And then we know that she has between 1 and 2 quarts of paint. So we'll put our variable for paint between 1 and 2. We also have her budget. Jane's budget is $65, and plywood costs 60 cents per square foot, planks of wood cost 10 cents per foot, and paint costs $8 a quart. So Jane's budget is $65. That means that her budget must be less than or equal to 65, since it can't go over that. So to get her budget, we need to figure out how much she spends on each material. If plywood costs 60 cents per square foot, then we'll represent this as 0.6p. And then she's going to add the cost of the planks of wood that are 10 cents a foot. So we'll add 0.1 for all of the wood she buys. And finally, we know that paint costs $8 a quart. So we'll add 8 for every quart of paint she buys. And since her budget is only $65, we'll set our equation equal or less than to 65. And now she knows what her budget is and how much each thing will cost. Let's recap everything that we've learned. Writing relationships as math expressions makes it easier to see what values a certain quantity could take. Keywords from the relationship will tell us what inequality symbol to use. We can use inequality symbols to represent relationships and constraints.